Hey everyone, welcome to my channel. In this session, we'll be learning what is GitHub Actions, what is GitHub Action components, what is the pricing of the GitHub Actions, what are the community actions. I will also show how to set up a custom runner, and at the end, I will show a GitHub Actions demo using Node.js. Okay, so let's get started. So, very first question you might have in your mind: what is exactly a GitHub Actions? So we can automate, customize, and execute our software development workflow right in our GitHub repository with GitHub Actions. We can discover, create, and share actions to perform any job we need, including CI/CD, and combine actions in a completely customized workflow. GitHub Actions are an automated process that allow us to build, test, release, and deploy any code project on GitHub. But we can also use it to automate any step of our workflow, such as merging pull requests, assigning levels, triaging issues, etc. So in short, GitHub Actions are a custom software development workflow automation tool. Okay. Now let's learn about the GitHub Action components. So we have following GitHub Action components: workflow, on events, jobs, runners, steps, metrics, environment variables, secrets, and cache. Let's learn one by one. So the very first one is the workflow. So workflow is a configurable automated process that we can use in a repository to build, test, package, release, or deploy our projects. Workflows are made up of one or more jobs that can be triggered by the GitHub events. Now let's learn about the workflow files. So workflow can be created inside the .github/workflow directory by adding a .yml or YAML workflow file. For example, add .github/workflows/build and deploy action.yml to a project. Okay. And what is the workflow syntax? So GitHub action files are written using YML syntax and have either a .yml or YAML file extension. Okay. Now, what is the workflow name? So this is the name of your workflow. This displays on a GitHub action page. If you omit this field, it is set to the file name. Okay, that's the default one. Next one is the on event. So the on keyword defines GitHub events that trigger on the workflow. We can provide a single event array or events or configuration map that schedule the workflow. Okay, so for example, you can see in the screen itself on push branches, then we're specifying the main branch, and you can see the array example when on and then third brackets push and pull request. We also have scheduled events. So scheduled events allow us to trigger a workflow at a scheduled time. Just for example, you can see the cron job. Okay. The third one is the jobs. A workflow run is made up of one or more jobs. Jobs define the functionality that will be run in the workflow and run in a parallel by default. Now, what is a job collection? A workflow usually consists of one or more jobs identified by a unique job ID. For example, you can see in the left image where I'm defining the job and saying the job ID is my job, right? And so this is the ID, that is my job. Okay. Now jobs run in parallel unless queried with the needs attribute, and each jobs run in a fresh instance of the virtual environment specified by the runs on keyword. Okay. And again, the needs identifies any job that need to be completed successfully before running the current job. Okay. Now the runs on. So runs on specified the type of virtual machine to run the job on. Okay. For example, Ubuntu latest, Windows latest, Mac OS latest, or maybe self-hosted. Okay. And we'll be discussing about self-hosted in a few minutes. Okay. Now let's discuss about the runners. So runner is a machine with GitHub Action Runner application installed. Then runners wait for available jobs it can execute. After picking up a job, they run the job's action and report the progress and result back to the GitHub. Runners can be hosted on GitHub or self-hosted on your own machines or servers. So let's talk about the GitHub hosted runners. So a GitHub hosted runner is a virtual machine hosted by GitHub with the GitHub Action Runner application installed. GitHub offers runners with Linux, Windows, Mac OS operating system. The virtual machine contains an environment of tools, packages, and settings available for GitHub Action to use. Okay. For Windows and Linux virtual machines, we have 2-core CPU, 7 GB of RAM, and 14 GB of SSD disk space. For Mac OS runner, we have 3-core CPU, 14 GB RAM, and 14 GB SSD disk space. Okay. Now let's talk about the self-hosted runners. So we can host our own runners and customize the environment in our GitHub Actions workflows. Self-hosted runners offers more control of hardware, operating system, software tool than the GitHub hosted runners provide. And the supported list as follows. For the Linux, we have rated Linux 7 plus. For the CentOS version 7 onwards, Oracle Linux version 7 onwards, Fedora version 29 onwards, Debian version 9 onwards, Ubuntu version 16.04 onwards, Linux Mint version 18 onwards. For Windows, we have support for 64-bit only, and the supported OS are Windows 7, 8.1, Windows 10, Windows Server 2020 R2, Windows Server 2016, and Windows Server 2019. For macOS, we have support from macOS 10.13, High Sierra or later versions. So the fifth component is the steps. So a job contains a sequence of tasks that is called steps. A steps can run commands and actions. The very first thing is the step name. Specify the label to display for the steps on GitHub. Let's learn about the users keyword. So it specifies an action to run as a part of the step in our workflow job. As you can see in the image, we are utilizing users action. Check out at the rate of version 2. Now let's learn about the with keyword. So it is a map of input parameters defined by the action in its action.yml file. For example, you can check the Node.js example where in the name we are mentioning use the Node.js and it uses action that is step Node.js version 1 with Node, and you can see the with keyword. Here we are mentioning what is the Node.js version, right? Now let's learn about the run keyword. So instead of running an existing action, a command line program can be run using an operating system shell. We can also run multiple commands using a pipe parameter. Sixth one is the matrix strategy. So a build matrix allow you to test across multiple operating system, platforms and language version at the same time. You can specify a build matrix using the strategy keyword and pass it to run on. Okay, so you can see in the example, in our example, in the run on we are specifying matrix OS, and then in the strategy, under strategy in the matrix we are mentioning OS is Ubuntu 16.04 and Ubuntu 18.04 and Node.js version 6, 8 and 10. In the steps, utilizing the setup Node.js version 1 with different Node.js versions, right? So this is how we can utilize the matrix strategy. The seventh one is the environment variables. GitHub sets default environment variables for each GitHub action workflow run. We can also set custom environment variables in our workflow using the env keyword. You can see in the image where using env keyword, we are mentioning the message and my token. Now, env defines a map of environment variables that are available for all the jobs and steps in the workflow. You can also set environment variables that are only available to a job or step. Okay. Now let's learn about the default environment variables. So GitHub Actions give us these environment variables as default. Okay. So the 8 components are secrets. So secrets are encrypted environment variables that we create in an organization, repository or repository environment. The secret that we create are available to use in GitHub Actions workflows. Sensitive values should never be stored as a plain text in workflow files, but rather as a secrets. Okay, and secret get access in a workflow like this: that dollar, then 2 second brackets, then secret dot the key name of the secret. Okay, and you can see in the example also I'm showing how I'm using it. So in the environment variables, I'm just copying the value of the secret into the super secret, right? So that's how you can also utilize it, and you can use the value any way you like. Okay. Secrets have a limitation. We can store up to 1000 organization secrets, 100 repository secrets, and 100 environment secrets. Okay, so make sure you remember the limit as well. Ninth one and the final one is the cache. So the workflow runs often reuse the same output as the previous ones and can therefore be cached for the increase in performance. Every job runs on GitHub hosted runners start in a clean virtual environment, doesn't use the cache by default, but of course you can turn it on and you can use the component, right? So caching is made possible by GitHub cache action, which will attempt to restore the cache based on the key you provide. If no match for the cache key found, we'll create a new one after the successful completion of the job. Okay, so now we should learn about the input parameters. So you can see input parameters, we need key and path. The key identifies the cache and is created when saving the cache, and the path, the file path of the directory you want to cache or restore. Okay, and restore key, an ordered list of alternative key to use for finding the cache if no cache hit occurred for the key. Okay, and output parameters are the cache hit, boolean variable with success state of the catch action. Okay, and you can see the example here how you're utilizing it. Before proceeding further, we should also learn about the pricing. GitHub Action usage is completely free for the public repositories and the self-hosted runner, which we will be configuring in a minute. Okay. For the private repositories, each GitHub account receives a certain amount of free minute and storage depending on the product used for the account. Okay. Any usage beyond the included amount is controlled by the spending limits. Jobs that run on Windows and macOS runners that GitHub hosts consumes minute at 2 and 10 times the rate of that jobs on Linux runners consume. Okay, so you can say the double of Linux is getting used by the Windows and the 10 times of Linux getting used by the macOS. Okay, if your account's usage surpasses these limits and you have a set of spending limit above 0 USD, you will pay 0.2 USD per GB of storage per month and per minute usage depending on the operating system used by the GitHub. So you can see here for the GitHub in the free private you will get GitHub free 500 MB storage and 200 minutes per month. For the GitHub Pro you will get 1 GB of storage and 3000 minutes per month. For GitHub free for organization 500 MB and 2000 minutes per month. For GitHub team you get 2 GB and 3000 minutes per month. For GitHub enterprise cloud you get 50 GB and 50,000 minutes per month. Okay, now minute multiplier which I explained already. For the Linux it's 1, for the Mac OS it's 10 times the Linux, that is 10 minutes. For Windows it's 2. Okay, per minute rate for the operating system, the Linux 0.008, for Mac OS 0.08, for Windows it's 0.016. Okay, now let's move to the next one. Now let's learn about the community actions. So usually actions are standalone commands that are combined into steps to create a job, right? Actions are the smallest portable building block of a workflow. We can create our own actions or use actions created by the GitHub community. The ones that are created by the GitHub community and ready to use are called the community actions. We can explore all the community actions in this links. Okay, so let me show you, and you can see at the time of the recording we can see 10,283 community actions are available. Okay, and for example usage you can see actions checkout at the rate of version 2. The users keyword tells the job to retrieve version 2 of the community action named action slash checkout version 2. This is the action that checks out our repository and downloads to the runner, allowing us to run action against our code. You must use the checkout action by any time your workflow will run against the repository code or you are using any action defined in the repository. And the second example is the setup node. So this step uses action slash setup Node.js at the rate of version 2 action to install the specified version of Node.js software package on the runner, which gives you access to the npm command. Okay, now it's time to set up our own custom runner and run our action in it. Okay, first we will be creating one repo, then we will go to setting of that repo and we will go to the actions, and then in actions runner we will go there and create our custom runner. Okay, so let's do that. Okay, so this is my GitHub account. Now let's create a new repo. So new repository, and let's call this repository custom runner test. Okay, now let's make sure it's private. Okay, so that other people cannot use my custom runner. So click on create repository. Now you can see the setting, click on the settings, and then in the very left you will see actions. Click on that, and there itself we can see general and runner. Click on the runner, and now you will see runners, and you will get the option to new self-hosted runner. Click on the new self-hosted runner. Now here you get three options for macOS, for Linux and Windows. We will be going with the Linux one. Okay, now for this demo we'll be utilizing our AWS EC2 instance. So let's create our EC2. So this is the screen you normally get after you log in into your AWS console. Now there, search for EC2, click on the EC2. Let's launch a new instance. So launch instances. For this demo we'll be utilizing Ubuntu 20.04 LTS. So let's select that and we'll go with the normal one. Okay, and review and launch. Just go down and make sure that in the security group port on is allowed, which is fine. Now click on launch, and I already have one for AWS DevOps that I normally utilize, so I'll go with that, and I acknowledge that I have the file, and I launch the instance. Let's go to the instance that you created and wait for a few seconds because it takes few seconds is to start up and ready to use. Now I will name it as runner. Okay, now it's up and running. Now let's click on the connect, and we will connect via the SSH client. So let's copy it. Let's SSH into this machine. Yes. Now we're logged into the EC2 instance, and now let's follow the instruction mentioned here. So first is to create, simply just copy paste the commands. First we'll create a folder. So let's go here and let's clean it up and paste the command, create the folder actions runner. Then we will download the latest runner package. So let's do that. Done. Now let's do the, no, you don't need to actually validate, it's all good, but just for the confirmation, let's validate. Okay, it all good. Now simply extract the installer, extract it. Done. Now let's configure it. And you can see authentication's done. Okay, and you can see is asking for enter the name of runner. Simply go with the default, and again just simply click on it, and it's just simply enter it, and that's done. Runner successfully added. Okay, now the final step is to run this. Okay, so let's run this. Run sh, and you can see it's saying connected to GitHub. Okay, now let's go back and click on the runners, and you can see it's active but in idle state. Okay, now let's run a simple workflow and see if it's working fine or not. So let's go to the custom runner test, and then let's create a file manually. Okay, so you can see create a new file. We'll be running a very simple code here, so let's do that. So the name of the workflow will be self-hosted runner test. It will be triggered on push. The jobs is in it, and it's running on, of course, the very important part here is running on the self-hosted. The steps are just running simple echo hello world. Okay, it's pretty simple. So start commit and commit the changes. Okay, and as soon as we just push the changes, if we go to actions tab, and if you go here, you can see, so you have to wait for a few seconds to it to complete. You can see it succeeded, and if you click on the job name, you will see all the steps. So first set up job, you can see, then run online script, run hello world. So that works perfectly, right? And it run on the self-hosted. You can see the machine name is a self-hosted IP. Okay, so it worked. Now I've shown you how to set up custom runners and run action in it. Now let me show you a demo of Node.js application, complete, build and release flow. Okay, let me explain the code first. So the workflow name is Node.js GitHub Actions demo, and on push and pull request, this workflow will run. In the jobs, we have two jobs. One is the build job, and second one is the publish job. So let's understand first what the build job doing. So build job running on Ubuntu latest, that is managed by the GitHub. Okay, and steps. First, we are checking out the code using the GitHub community action checkout. Then you're utilizing again another community action, that is action setup node, and it's a version you're supplying 14.x. Then you're installing dependencies, you're running npm install, then you're running npm run build if present, and then you are zipping it. You can see you're running a shell script here. Then you are uploading the artifact. You can see here we are uploading the artifact in a zip bundle. Okay, that is the zip drive created here. So in the build phase, we are exporting the artifact, that is the GitHub SHA zip. Then in the publish job, we are running on Ubuntu latest. Okay, that is again managed by the GitHub. Then in the needs, we are waiting for the build to finish, because if you don't mention it, it will run parallelly, and we want to first get the zip bundle, then only run all that, right? So we have to wait for the build to finish. So when the build is done, then the next step is to create a release, and you can see we are again utilizing the community action, that is the action create release. Then you are utilizing the GitHub token. Now again, GitHub token is also available by the runner itself. You don't have to worry about supplying the environment variable. And with we are supplying all other parameters. There's the tag name, release name, body, is it draft, is it pre-release, or false. Then we are downloading the artifact. Again, we are utilizing the community action, that is action download artifact version 2, and you are utilizing the zip bundle. And then you are uploading the release asset. You can see action upload release version 1. Again, we are supplying the GitHub token with upload URL steps dot create release dot output dot upload URL that you get in the create release phase. Then you are adding the asset path. You are giving the asset name, that is source code with npm modules, and in the finally you are giving asset content types application zip. Okay, now I have explained the code. Now let's see in the action. In our index file, you can see it's very simple Node.js code. Now let's add a service too. Okay, just for example, and let's add it. So we call it service 2, and let's call it service 2. Okay, now let's check for the changes. Okay, this is the change. Now git add index, git commit, and say service 2 changes, just for example. Okay, and commit it. Now push it, virgin main, and yes, it's pushed. So as soon as the code is pushed, if you go to actions tab, and you can see service 2 changes, and first is the build. You can see build job is running, starting the job. It will take few seconds. Let's wait for that. Now all the build job is completed. Now let's wait for the publish. Let's wait for it to finish. You can see the create release is done, download artifact is done, upload release asset is done, and it's completing the job. As soon as it's completed, we can check our release. So publish job is also now completed. Now if you go to code, and you can see the release 8, click on that, and it has the, you can see source code with the npm module zip, and it exactly matching with the value we have set here, right? So it's working perfectly fine. In the next week, I will show you how to upload the GitHub action artifact in the S3. Okay, wait for that. Again, if you do like the session, please do subscribe to the channel. Click on the bell icon so that you will get notified whenever I upload the next video. Okay, thank you very much. Hope to see you again. Okay, bye.